Let's start the new topic AC generator by watching this animation. See, this is the AC generator is a simple machine which is used to convert the mechanical energy to electrical energy. See, this thermal power station are shown in this figure and many other power stations in which the AC generator is used. So starting with its definition, here AC generator is a device that converts mechanical energy into kinetic electrical energy that I already told you. This was first invented by Nikola Tesla. What are we going to study in this particular chapter? First principle, then components of AC generator, and then working and their graphical representation. So see, the working of AC generator is totally based on electromagnetic induction. See, whenever this magnet is placed into the circular insulated wire, the galvanometer is showing the deflection. For the direction, we are having the two options. The first is Fleming's rule. The Fleming's right hand rule is stated as stretch the forefinger, the middle finger and the thumb of the right hand such that they are mutually perpendicular to each other. If forefinger indicates the direction of the magnetic field, then the thumb indicates the direction of motion of the conductor and the middle finger indicates the induced current in the conductor. Now see, this law is very important because we have studied it. It states that the direction of induced current is such as opposed to any type of motion. Now we will see some components of AC generator. So first of all, magnetic poles are coming, north pole and south pole. Then there is one armature, that is current conducting coil. We have used slip rings, brush and the galvanometer. Now we will see the work of armature first. It is a soft iron core on which a coil having a large number of turns of insulated copper wire is wound. Then comes, so first part was of electricity, now comes the magnetic branch of physics. This is the magnetic poles. We also have slip rings, which are the ends of the armature are connected with two slip rings. They rotate along with the coil. The slip rings are made up of metal and are insulated from each other. Here the brushes B1 and B2 are made up of carbon. One end of each brush is in contact with the rotating slip rings and the other end is connected with the external circuit. Here, if you see, the brush is connected to the galvanometer and by rotating the armature, the galvanometer shows us the deflection. So, what is the actual working that the galvanometer is showing us the deflection? So, this is the working principle and in which the rotating armature is make the change in magnetic flux of the ring and that is inducing the EMF, and due to that induced EMF, that means the change in the magnetic flux related to the time, we are getting the deflection in the galvanometer. Now if you see the voltage versus time graph of such event, then this graph would be comes out to, first of all it is increasing, then it decreases. So it is depending on the motion of armature, totally depend on the motion of coil. So in this way we can obtain the graph of the AC generator and this will be sinusoidal type of graph. And now we will switch on to some analysis of the AC generator. So after studying the working principle and about the introduction of AC generator, let's start some analysis, and for the analysis I am giving you one structural arrangement of AC generator. But first of all, let me write the principle of AC generator. convert mechanical energy into electrical energy. Now, we just consider the arrangement of AC generator as below. So here the arrangement of AC generator is given as similar to that of we have seen in the animation. Here A1 and A2 are the slip ring and B1 and B2 are the carpet brushes. Now, when the coil is rotated with a constant angular velocity, that is equal to omega, and this coil will now rotate in a uniform magnetic field. Then the angle between magnetic field vector, so the angle between B and A at any instant t is given by omega t. So here we are assuming from theta is equal to 0 at time t is equal to 0, and with this assumption now I can find out the magnetic flux of the coil, and I am also assuming the number of turns in the coil is capital N, and so the magnetic flux is given by phi is equals to BAN cos theta. But here the value of theta is omega t. So replacing theta by omega t in this equation also. So my equation for phi is equals to BAN cos omega t. Now, the EMF which is induced in the coil is given by Faraday's law. Because here now we have to find out the magnitude to start our analysis. So according to Faraday's law, the induced EMF is epsilon, but here I am taking in terms of voltage, because here I have used the galvanometer to measure the current, and so current is related to voltage according to Ohm's law, and the remaining things are as it is. So putting the value of phi in this equation is equals to minus d by dt BAN cos omega t. Now see, which are the things that are constant with respect to time? That means they are not changing with respect to temperature. So they are magnetic field induction, area, and the number of turns. So I am taking this much quantities outside the differentiation. So therefore V is equals to minus VAN. Now this cos omega t's differentiation with respect to time is minus sin omega t. And this omega is the coefficient of time, so it will also come in the multiplication. Now this minus minus will become plus. So the final equation for induced EMF is BANW sin omega t. So this is my second equation. Comparing this equation with V is equals to Vm sin omega t, where Vm here I am using for maximum induced EMF in the coil. Here the first equation was this. So this equation suggests us, equation number 3, that the induced EMF in the coil varies as the function of sin omega t. Now, if you consider the slip rings and the brushes which are given in the figure as well as we have seen in the animation, but what will be the kind of nature of the magnetic flux as a function of omega t, as well as what will be the nature of voltage as the function of omega t. In both the cases, I am giving my limits to 0 to 2 pi, and in this case the limit of omega t is also 0 to 2 pi. And with this I am drawing the graph of this first and second relations. So these graphs would be comes out as, so this is the graph which is showing us the relation of magnetic flux at time t to the omega t. Now see, if you want to see the actual reason for having this graph, so we will do such analysis, but this is the actual graph of, see, at pi by 2 the function is becoming 0. So this can be the cosine type of nature, and at pi by 2 the value is become maximum. So this graph can be said of sinusoidally type of nature. Now we have the equation of V is equals to Vm sin omega t. Here first of all substituting the value of omega t as pi by 2. So Vm sin pi by 2, and we know the value of sin pi by 2 is 1. So therefore at omega t is equals to pi by 2, the value of V is plus Vm, and see, similarly at 3 pi by 2 the value is minus Vm. Now you check for this, pi is equals to Van cos omega t, in which substituting the value of pi by 2, so Van, therefore pi is equals to Van cos omega t is equals to Van cos pi by 2, that is equal to 0. And you can clearly see from the graph at pi by 2 the magnetic flux is 0. Now here you have considered this omega as constant angular velocity. That means you have to choose a particular range or the frequency in which this velocity is constant. So here we are taking for AC current Omega is equals to 2 pi f, where f is the frequency of revolution of the generator's coil. And now I am substituting this value of omega into the velocity. Therefore, V is equals to, or this is induced BMF, Vm sine 2 pi f t. So this is the final equation, and let us see some applications of AC generator. So first, in commercial generator, the mechanical energy required for rotation of the armature so there is a requirement of mechanical energy for the rotation of armature, that is called, or that is provided by water falling from the height. And such generators are called the hydroelectric generator. The another application of AC generator is for the water is heated to produce steam using coal or other sources. Now, the steam at high temperature or at high pressure, instead of temperature, I am using the pressure that produces the rotation of armature. And that is called thermal generator. In the same process, instead of using coal, if a nuclear fuel is used, then such generators are called The nuclear power generator. So here we have studied three different types of generators. First was hydroelectric, the second one was thermal, and the third one was nuclear power generator. Now, in the modern day generator produces the electric power as high as 500 megawatt. Also, what do you mean by this 500 megawatt? So one can light up 5 million 100-volt bulbs. That means 50 lakh, around 50 lakh 100-volt bulbs can be produced or can be light up by the use of modern generators. In most of the generators, the coils are held stationary and it is the electromagnets which are rotated. In India, the frequency of AC, this can be asked in MCQ. Is 50 Hz. So what will be the angular velocity? It is 2 pi f, so it is 100 pi. And in certain countries like USA, the frequency of AC is equals to 16 Hz. So with this now our theoretical portion is over and we will see the last illustration of this chapter related to AC generator.